Good morning students, I am your Nagini ma'am. Today I am going to discuss about the tetrahedral and octahedral wires. Okay, how to find tetrahedral and octahedral wires I am going to discuss students. So first of all, what is the wire? How many types are there that are discussed? Okay, so first of all, wired. What is wired? What is wired students? Empty space. Empty space or free space present in the unit cell, present in the unit cell. Clear? So this is called wired. Clear? So empty space or free space present in the unit cell is called wired. Okay students, now this wired is classified into how many types? Two types. One is tetrahedral wired, tetrahedral wired, and the one is octahedral wired. Okay, tetrahedral wired, octahedral wired, two types are there. So this tetrahedral wired, what is the definition? Tetrahedral wired, what is the tetrahedral wired? The wire which is present in between the four atoms is called tetrahedral wired. Octahedral wired means the wire which is present in between the six atoms is called octahedral wired. Okay students, now see what is the definition tetrahedral wired. The wired which is present between the four atoms. Okay, what is octahedral wired students? The wired which is present between the six atoms. Okay, between the six atoms, this is octahedral wired. Clear students? The wire which is present between the four atoms. Okay, I am taking the four atoms students. Now see, this is three atoms are in touch with one another, and fourth atom I am taking, this is fourth atom students, I am taking just above the three spheres students, above this piece, three spheres. Now see, I am keeping this fourth sphere above these three spheres, will get the empty space, correct? Here this is empty space present between the four spheres or four atoms is called tetrahedral wired. Understanding? This is called tetrahedral wired. Understood? That means the wire which is present in between the four atoms is called tetrahedral wired students. Tetrahedral wired. Okay, now coming to the octahedral wired, the wire which is present between the six atoms. Now see, six atoms, this is four atoms. Now fifth atom, it is present at the top of the four spheres, and the sixth atom is present bottom of the four spheres students. That means this is the fifth atom, it is present at the top. Okay, and the sixth atom, it is present at the bottom. Okay, at the bottom of the four spheres. That means how to take students this one diagram? See once again, these four spheres are in the same plane, are in touch with one another, and fifth sphere is this one. Okay, this is the fifth sphere. Now see students, I will give you the clarity once again. See, 1 2 3, this is the fourth sphere, and fifth sphere is present at the top of the four spheres, and the sixth sphere is present at the bottom of the sixth sphere students. So this empty space is called what? This is octahedral wired. Octahedral wired. Clear? This is octahedral wired students. See, suppose here I am taking the here one sphere, first sphere, second sphere, third sphere, and fourth sphere. Okay, they are in touch with one another, students. And the fifth sphere is present like this. Fifth sphere is present like this at the top of the four spheres. These four spheres are in touch with one another, and fifth sphere is present at top of the four spheres, and the sixth sphere is present present at the bottom of the four spheres, students, like this. Okay, here down, understanding? So like this you have to take, students, at the bottom, like this, bottom of the four spheres. Clear? This is fifth sphere is present at the top of the four spheres, and sixth sphere is present at the bottom of the sphere. Clear this one? Like this. Okay, now tetrahedral wire, octahedral wire definitions completed. Now we are going to discuss types of wires, students. Okay, now types of wires. Types of wires in FCC, students. Okay, in FCC we are discussing. Okay, so we know that the number of particles present in the FCC unit cell is equal to 4, correct? So FCC Z value, how much, Nana? Z is equal to 4. Clear? So here Z is equal to 4 in FCC. The number of particles in FCC, Z is equal to 4. Here in FCC, Nana, total tetrahedral wires, so octahedral wires both will be there. So Z is equal to 4 means how many tetrahedral wires are present in FCC, and how many octahedral wires are present in FCC, students? Z is equal to 4 kada FCC. So here Z is equal to 4. How many tetrahedral wires and octahedral wires? Now I am taking the tetrahedral wires, students. Tetrahedral wires, how many? 8. Clear? Because Z is equal to 4 kada. So that means the number of particles present in the FCC is equal to 4. Then how many tetrahedral wires you will get? Double the number of particles present in the FCC. That means Z is tetrahedral wires we have to take 8. 2 4s are 8 kada. So double the number you have to take. Now coming to the octahedral wires. Octahedral wires, how many? 4 only. Octahedral wires are 4 because here tetrahedral wires we have to take double the number of particles, and octahedral wires we have to take same as that of the number of particles present in the FCC. Same value you have to take, students. This is tetrahedral wires, octahedral wires. So 8 tetrahedral wires are present in FCC and 4 octahedral wires are present in FCC, students. Clear this one? Now first I am going to discuss about the octahedral wires. Okay, so first I am discussing about the octahedral wires. So octahedral wires, Nana, where we can observe octahedral wires total 4. In this 4 where these 4 octahedral wires, where in FCC where it is present, now will discuss. So octahedral wires, Nana, these we can observe at at the body center and at the edge center, students. Okay, now so that means one octahedral wire we can observe at the body center, and 3 octahedral wires, correct? That means 3 octahedral wires we can observe at the edge center. Clear this one? Edge centers. Now see, students, body center. Now octahedral wires we can observe at the body center. So at the body center, one octahedral wire we can observe, and at the edge center and the edge centers, 3 octahedral wires we can observe. Clear this one? So one at the body center and three octahedral wires are present at the edge center. I will show you this one how at the body center one octahedral wire how it is. Okay, now I will show you Nana. So first of all, what is FCC, students? We know that in FCC total 8 corner particles plus 6 face center particles will be there, correct? Now we'll discuss FCC structure. This is FCC. Here these are corner particles. Okay, these are corner particles. So and what will be there, students? Phase centers kada, total 6 phases will be there in the unit cell. So that's why 6 phase center particles I am taking. Now see, this is the top and this is the bottom, left to right to And next, this is the back face, this is the front face, correct? Now this is the top face center, okay, and this is the left face center, this is the, this arrow, this is top, this is bottom face center, this is the right face center, and this is the left or right over, and top bottom where bottom over, and this is the front face kada, this is the front space center is here, and back face center is here. Understanding? This is the back face center. Are you understanding? Total 6 face centers will be there. Yaru, this one face centers, okay, and this one corners, okay, corners will be there. So now first I'm going to discuss about the body center. That means one octahedral wire is present at the body center kada. How body center at the how octahedral wire, how, where it is formed, we will discuss students. Now I'm taking the body center diagram I'm taking, students. That means here octahedral wire, one octahedral wire is formed at the body center na. So I'm taking the diagram, I will show you. Okay, this is the unit cell. Okay, now see students, this is the unit cell. So here in the unit cell, what will be there, students? Total corners will be there, face centers particles will be there. Now I am taking only face center particles, students, only face centers particles I am taking. Now see, where is the face center particles? This is the top face center, this is the left face center, this is the right face center, okay, and this is the down face center. Understanding? And here this is the front face center, and this is the back face center. Clear, students? This one only face centers I'm taking. Now these face centers, if you see this one, these face centers are in touch with one another, correct? This one, this one, this one, these four particles or atoms are in the same plane, and here this particle is present at the top of the four spheres, and this sixth center particle is present at the bottom of the four spheres, students. Now see here, this empty space is there now. This empty space is called yaru, it is octahedral wire. Clear this one? So this octahedral wire where is formed, students? At the body center, correct or not? So what is octahedral wire? The wire which is present in between the 6 particles, 1 2 3 4 5 6. These 4 particles are present in the same plane, and the 5th sphere it is present at the top of the 4 spheres, and the 6th sphere is present at the bottom of the 4 spheres, students. So here we can observe one body center. At the body center, one octahedral wire is formed. Clear this one? That is about the body center particle octahedral wire. Clear this one? Now I am going to discuss the edge center. So this is at the body center, correct? So the octahedral wire is formed at the body center. Clear this one, students? Now see here, octahedral wire is formed at the body center. Clear? So how many will get octahedral wires at the body center? Only one body, only because this body center particle it is shared to that particular unit cell only kada. So that's it, does not sharing with other unit cells. So that's only one octahedral wire is formed at the body center. Clear this one? And coming to the edge centers, how at the edge center we will get the octahedral wire. Now see students, diagram if I take edge center diagram. See, I am taking this one corner particle, these two are corner particles, and this is the top face center. I am taking one particle at the top face center, and one more is this is the back face center. This is arrow, this is top, this is bottom kada. This is front face center, this is the back face center. I am taking the front face center, students. This one, Okay, this front face center I am taking, front space center. Clear? And here if you take the above this unit cell, one more unit cell will be there, so we know that adjacently about the to this one remaining nearly 7-8 unit cells will be there. Correct? I am taking the first this one, and then to this above this one unit cell I am taking. So to that one, top front the top face top face center is where it is. The top face center particle is where, here it will be there. Okay, and here this unit cell above this one unit cell we are considering, that unit cell front face, that is top face center this particle, and from this one, this front face center I am taking, students. I am taking here front space center. Okay, now see, these four spheres are in touch with one another, and here this one this is the top, and this one is the bottom. Correct? Here there is an empty space, here there is an empty space. Correct? So this is the empty space, students. This empty space is called, where it is formed this space, this is edge kada, this is at the edge center. Correct? This is the octahedral wire, because the wire which is present in between the 6 atoms kada, this one 6 atoms, and this wire is formed at the edge center. Are you following, students? Here what I am taking, here two corner particles I am taking, this top face center particle, this one, this top face center, and this is the back face. Are you understanding? This is the back face center. Okay. This is the back face center, students. This is the front face. Correct? This is the front space, front face, and this is the back face center I am taking. And here above this one more unit cell will be there. Just you have to consider that one, that one top face center particle is this one, and this one back face center particle is this one. Now these four particles are in touch with one another, and this is the fifth particle. It is present at the top of the four spheres, and sixth present at the bottom of the four spheres, students. So that means this sphere is formed at the edge center. Correct? So that's why here at the edge center we can observe the octahedral wire, because the wire which is present in between the 6 particles kada, 1 2 3 4 5 6, so this is the wire. This is arrow octahedral wire. Okay, octahedral wire is formed. Clear? Then how to find the how many octahedral wires are formed at the edge center, students? How to find this one? Now see how to find. So total how many edge centers, students? Total edge centers 12 kada. Total edges 12 will be there. Edge centers 12 will be there. And each edge center contribution is how much, Nana? Each edge center contribution is 1/4 kada. 1/4. Then how much you will get? 3 you will get. That means 3 octahedral wires we can observe in the FCC structure, students. At the 3 octahedral wires we can observe at the edge centers in FCC. Clear this one? Octahedral wire is formed. That means 3 octahedral wires are formed at the edge centers. Clear, students? At the edge centers in FCC. Clear? In FCC we can observe the total how many? 3 octahedral wires. Clear this one? Here octahedral wires is total. Here once you again see, students, here number of particles how many, students? That is equal to 4 kada. So here this 4 particles where will be there? Here actually number of particles in FCC z is equal to 4. How many tetrahedral wires will get? Double the number of particles in FCC. How many octahedral octahedral wires will get, students? Same number of particles present in the FCC. So here octahedral wires first I am discussing. So in octahedral wires, students, total 4 wires are there. Now these 4 wires where is formed? So first one octahedral wire we can observe at the body center, and 3 octahedral wires we can observe at the edge center, students. This is 3. That means here total 3 edge centers we can observe. 3 octahedral wires are observed at the edge centers. Okay, clear this one? That means 3 octahedral wires are formed at the edge centers. So total 3. Here at the body center 1 octahedral wire is formed. How to find it? Total 12 edge centers. Each edge center contribution is 1/4. Total value 3. So 3 octahedral wires are formed at the edge centers in FCC. Clear this one. So octahedral wire is completed. Clear. Now I am going to discuss about the tetrahedral wires. How many tetrahedral wires are formed, students, in FCC? 8 tetrahedral wires. Now I am going to discuss about the tetrahedral wires. Now see, students, tetrahedral wires. Clear? Tetrahedral wires, how many are there? 8 tetrahedral wires kada. So in the see here already I discussed you here. So total how many tetrahedral wires? 8 kada. So octahedral wires 4 I discussed, correct? Now I am going to discuss about the tetrahedral wires. You will get the total how many tetrahedral wires? 8 tetrahedral wires you will get in FCC. Clear? So here see, students, diagram tetrahedral wires in FCC. I am taking diagram. Okay, now here I am taking the one corner particle, and this top face center is this particle. Okay, this is the left face center, here one particle, and this is the front face center. Sorry, this is arrow, this is a front face, and this is the back face kada. Now I am taking the back face center. Understanding? So back face center I am taking. Clear this one. Back face center. This is the back face. This is a front face kada. This is the back face. So sorry. This is the front face center. Clear? I am taking here. Not this one. See. So one corner particle I am taking. This is the top face center. This is the left face center, and this is the this is arrow back face. This is the front face. This is the back face center, this one. Okay, now these 4 spheres are connected. 4 spheres connected kada. See how they are connected. Like this. That means these 4 spheres are in the same plane, and this space is there, na empty space. Okay, this space is called arrow wired anamata. This is a tetrahedral wired. Means the wire which is present in between the 4 atoms kada. 1 2 3 4. This is called tetrahedral wired. Understanding? This tetrahedral wired, where it is formed inside the unit cell kada. Inside the unit cell. Clear this one. And it is formed near to the corner. Clear? So how many corner particles will be there? How many tetrahedral wires? How to find? Total 8 corners. And this tetrahedral wire, how many tetrahedral wires are formed? Only one. Okay, at the each corner. And this corner, this its contribution is how much? Because this tetrahedral wire, it is present inside the unit cell, that's why its contribution is 1. Understanding? So total how much, students? 8 tetrahedral wires will get in the FCC. Clear this one? So tetrahedral wires are formed at near to the corners. Clear? Formed at near to the corners. Correct? This is tetrahedral wire. It is formed at the near to the corner, students. This is the near to the corner. Total 8 corners will be there now. Total how many corners? 8 corners. So that's why how many tetrahedral wires will get, students? Near to the corner, one tetrahedral wire is there. 8 corners are there. That's why we will get the 8 tetrahedral wires will get. 8 tetrahedral wires will get. Understanding? 8 tetrahedral wires will get. So this is about the tetrahedral wires present in the FCC students. Clear this one? Okay. I hope you to understand this video. Thank you, students.